Hello and welcome to another Zodian session. So I decided to make a very quick Zodian session just to fix one of the problems that we had in Emote Jam. Emote Jam is a website that generates animated emotes for BTTV and stuff like that. If you never heard about it, you can find it in the description. And of course, it is completely open source. You can find the source code in the description as well on GitHub. Source code. Okay, so one of the things we did recently, we migrated this website from JavaScript to TypeScript. So there's a recording of the session where we did that. You can find it on YouTube. I'm going to leave the link in the description as well. It has a bright thumbnail. You will instantly see it. Thank you, YouTube. YouTube knows what I want. All right, so JS to TS migration stream. Right, so you can find it in here if you're interested. So, and we have one of the components of the application that we have is an expression evaluator. Right, so we have our own expression evaluator that accepts a small subset of JavaScript and allows you to evaluate it in a very sandboxed environment without using the actual JavaScript eval. We developed this entire thing as well on one of those Zodian sessions. I will leave the link in the description as well. I think I don't quite remember what it's called. Zodian Daily. I think it's called like implementing JavaScript in JavaScript or something. It should be available. Excuse me. On my channel, yeah, this one, re-implementing JavaScript in JavaScript for safer eval. Right, so for more context about what this component is, you can watch this stream, safer eval. Okay, what's the problem? So first, what we can do, let me enable fly check. I think I should actually enable fly check in my Emacs configuration, but I couldn't bother to actually do that right now. Essentially, imagine that you have an expression like this, 1 plus 2 multiplied by 3. So the first thing you do, you compile that expression. You do compile, compile export, and there we go. And this entire thing will return you, well, it's supposed to return you an expression, right? So, and I think I forgot to actually update my bindings. Right, there we go. So it is supposed to return you an expression. What you can do then, you can run that expression. Autocompletion doesn't want to work. Yeah, there we go. And when you run this expression, providing the user context, we didn't provide any user context because we didn't use any custom variables or functions. It will return you a number, right? And then we can try to print this entire thing just to see what's going to happen. So according to, you know, common mathematical sense, this should be 7, right? So 2 by 3 is 6, plus 1 is 7. If we try to run this entire thing using the node, I think I forgot to recompile this entire stuff. So let me actually run the node in watch mode, so it constantly recompiles everything I type. Okay, no errors were found, and now I can try to run my JS eval JS, and as you can see, it actually printed 7. Precisely what you would expect. Precisely what you would expect if I actually increase this kind of thing. So this is going to be 9 because 2 by 8. 2 by 4 is 8, and plus 1 is going to be 9. Okay, so what's the problem? The problem is that our evaluator doesn't take into account the binary operator precedence, right? Usually the precedence of the multiplication is higher than the addition, and this thing works completely accidentally because of our parser actually interpreting this expression like this, right? If the associativity of the parser was a little bit different, it would not work, right? It would not work. Right, so we can break this expression by actually swapping these arguments around. What if it was 2 multiplied by 3 plus 1, and let's see what's going to happen. Suddenly, instead of being 7, it became 8. The question is why? Because again, our parser interpreted it as this. Right, so first it actually added 3 plus 1, which is 4, and then multiplied by 2. Right, what's interesting is that in the session where I was developing this entire system, in the re-implementing JavaScript and JavaScript, I actually mentioned precedence of the binary operators, but then I completely forgot to implement it. So I mean, yeah, it works for now, but it needs to be fixed. I think at some time ago, the calculator on one of the versions of Windows also didn't take into account the precedence of the binary operators. And yeah, it's actually super easy to forget to do that, to implement this specific feature. Okay, and I think I even have an issue for that. So let me see. Precedence of the operators is not handled properly in the duration of the filters. Yeah. So it's an issue 66. Okay, let's go ahead and try to fix that. So I'm going to create a separate branch, and we'll see. Also, this one is a very important change. I'm going to actually commit it in the scope of 66 issue. All right. 6 make compile expr return expr. Nice one. Okay, cool. So what's the first thing we gotta do? We need to establish a table, the correspondence table of the binary operator and its precedence. We already have a table which actually establishes the correspondence between the binary operator and the function that is applied to that specific binary operator. Maybe we can actually store the precedence operator in the same place, right? So maybe it would make sense to introduce some sort of interface, and that interface is going to be binary operation definition, right? And the binary definition operation definition consists of the function, which is the binary operation function, and its precedence, which is going to be a number, right? There we go. And that way, so this is a binary operation, and this table is going to contain not functions, but their definitions. So that completely breaks everything. So that means we have to go ahead and fix everything. So this is going to be the function and the precedence. So plus and minus have the lowest precedence. So we're going to actually set it to 0. All right. Minus is going to be also the same precedence as the plus, and all these three, they have a higher precedence than plus and minus, so they're going to be 1. Func precedence 1, and let's just close this entire thing, and then func precedence 1, precedence. I don't even know how to pronounce that word correctly, to be fair, but I don't speak English, so I'm allowed to mispronounce words. Right. All right, so that definitely broke all of the places where we use binary ops. So let's actually go to those places and try to fix them. So what we're trying to do in here, we're trying to actually invoke a function. So I think it has to be something like this. Can I actually like print that a little bit? So I run the function, then this is my expression. Actually, I run to expression. Okay, so that looks a little bit better. Yeah. What's the next one? And I guess that's it. So we don't even have any problems in here. So that was the whole refactoring, which is pretty nice. So now we need to parse everything according to the precedence. So if we take a look at the expression, some sort of expression, 1 multiplied by 2 plus 3 multiplied by 4 plus 5 multiplied by 6. Right, so we're basically going to have a function that sort of climbs the precedence, right? We're not going to implement the precedence climbing, but we're going to implement something that precedence climbing try to optimize, right? So there's a recursive scheme which actually can be boiled down to precedence climbing. And if you never heard about precedence climbing, I'm gonna leave the link about this thing in the description. So we're not implementing precedence climbing per se, but we're implementing this recursive scheme that is explained in the Wikipedia article about precedence climbing. So I'm gonna leave this entire thing in the description as well. Precedence parsing scheme we are using. We're going to implement the precedence climbing a little bit later, right? So for now I just want to keep the things a little bit simpler, though precedence climbing itself doesn't really look that complicated. It's just like I didn't have time to wrap my head around it, right? So it seems to be less recursive, than, you know, direct implementation of this entire thing. But I don't know, maybe at some point actually I will make a session where I will try to look into the precedence climbing. As a matter of fact, let me actually write it down as a topic, as a possible topic of the coding session. Precedence climbing. Right, so this is going to be, yeah, I write my down I write my topics down on a piece of paper. Right? As an epic programmer, I trust paper more than I trust computer. As a matter of fact, me being a programmer for 15 years actually taught me that you should never trust computers. So the more I program, the more I realize that trusting computers is the last thing you want in your life. So believe me, I trusted computers way too many times and I was burned by that way too many times. You never trust computers. Don't trust them. No. Choose. All right. So, okay, so we have this thing. Why do we have two Emacs open? I'm not quite sure. So this is one. Oh, I see. So I have one separate Emacs for description and one separate Emacs for editing. I don't know why. It's not very Emacs of me, right? Because you usually have a single Emacs for everything. All right, so essentially we have this expression and we start parsing with the precedence 0, right? So that means the first thing you want to try to do is to parse, like basically chop off an expression with the precedence p+1 off of this entire thing, right? So essentially we have some sort of a function like parse, and the it's starting precedence, right? So this is going to be the input. That's actually very unfortunate. I wanted to do something like this. So this is going to be the input, and this is our recursive function. So and an input is going to be somewhere here, like this, right? So first we want to try to do, we want to chop off an expression with the precedence +1, right? So, and essentially what it will do, it will go recursively back into parse, and now it will try to basically chop off this entire thing, right? So after this call, the next token, right, the next token must be equal to plus, right? Or rather, the precedence of that token, right, precedence of that token must be equal to the precedence that we expecting in here, right? They must be equal. If they're not, I guess we can just basically return this expression back. So this is going to be left-hand side, and for instance, if this is equal, then it's fine, but otherwise it is going to be returned like this, right? There we go. So after that, since we already removed a token from the input, what we need to do, we need to parse the right-hand side of this expression, and we're going to be parsing it as the expression of the same precedence. As you can see, so the expression that we're trying to parse is the precedence of plus, but then we have another one which is of the same precedence. And this is going to be our right-hand side, right? And then after that, we're essentially returning the AST node with the left-hand side and right-hand side. So yeah, that's basically the modification that we have to make to our parsing scheme. And I don't know why I'm writing this in pseudocode, because it's almost the JavaScript code that I need to write in my project. Yeah. So, and another interesting thing is that if the precedence, right, if the precedence is greater or equal than the maximum precedence, right, in our case, the maximum precedence right now is 2, that means we're trying to parse this thing as a primary expression, parse primary. Yeah, it's going to be like that. And yeah, we can instantly return this. And primary expression is basically anything that is not related to the binary operators. It's like numbers, variables, function calls, or expressions wrapped in parentheses. So what's interesting is that the expression that is wrapped in parentheses, it basically resets the whole precedence climbing scheme and starts like sort of from the beginning again. So yeah, let's go ahead and implement this entire thing. So I need to do what? I need to establish some sort of a constant max precedence. Oh, by the way, I remember that TypeScript had enumerations similar to like C. Can I use enumerations for precedence in here? Let me actually check it out. TypeScript enumerations. Handbook enums. I already looked into them. And that's why I remember them, because I already... Yes! Mine got... This is actually pretty cool. So we'll start off with the numeric enums, which are probably more familiar if you're coming from other languages. Enum, above we have a numeric num. Okay, that's pretty cool. Must have, enum member must have initializer. Really? Okay, so let me try to just experiment with this entire thing, and we'll see how it will go. Enum precedence, like binary precedence, right? And so what we're gonna have in here is basically precedence 0, which is initially 0. Then we're gonna have 1, right? So is it totally fine? Okay, and then we're gonna have max precedence. Max precedence. Will that thing work? Right, and then I'm gonna try to do something like binary precedence. There we go. So this one seems to be working. So precedence 0. Okay. Huh. Binary precedence. Do I have to do something like this to make it? Yeah, apparently. So I don't like the word precedence because it's very, very huge. So can we, I don't know, make it a little bit shorter? Maybe query replace precedence, precedence with prec. And something like that. Yeah, probably. Yeah. Yeah, so we have func and prec. Nice. This is not really maximum precedence. It's sort of like a count prex, right? So count prex. After that, yeah, we need to do something like this. Binary prec. Prec 0, then might as well actually just copy paste this entire part and just put it like that. So this is going to be binary prex. And I'm really curious what will be printed if I try to print binary op, binary prec count prex, right? So count prex. And let's just go ahead and print that. Okay, so there's 2 of them. Nice, nice, nice. So this is the amount of precedences we have. All right, so that's pretty cool. So parse expression. We don't have a function called parse expression. For some reason, it's called just parse. I would rather prefer to actually call it parse expr. So that will probably introduce a couple of errors in here. Yeah, okay, so here they are. For some reason, it doesn't want to jump to the errors. But yeah, we definitely do have like errors. Parse expression, right? Another one. It doesn't want moved past last error. Okay. Restart the server. Flight check. Flight check. It doesn't want to move to the next error. This is so embarrassing. Okay. This is actually very sad. So if I introduce some sort of an error in here, right? Will it allow me to move? Flight check next error. Okay, I guess we have to use it like that then. Usually it works without any problems, but something got broken in my Emacs, so there's nothing I can do about that. Emacs, am I right? But Soizin, why you don't use Visual Studio Code? Visual Studio Code. So, alright, so I think I refactored everything. And again, I need to go into the parse expression function. Here it is. And one thing we probably need to do here, we need to introduce the precedence, right? So we need to introduce the precedence, and it's going to be prec. And in fact, it's going to be binary prec. There we go. But initially, it is going to be a binary prec 0. Binary prec 0. Yeah, there we go. So, and again, if the precedence is greater or equal than binary prec count, precs, we're just parsing this entire thing as a primary expression. Parse primary lexa. There we go. Otherwise, we're trying to parse the left-hand side, as we already mentioned, we're trying to parse the left-hand side as the expression with the higher precedence, right? So we have to do something like parse expression, but the prec is going to be +1. You see? There we go. Okay, and now we take in the operation token, right? We take in the operation token, and we're checking that it is in... Oh, this one is very interesting. So we are checking that it's not null, that it exists, right? Then we probably want to check that it is located in the binary operations. And if it is located in binary operations, we have to take binary OPs, op token precedence, right? And it's equal to the current precedence. If it is equal to the current precedence, we keep parsing this entire thing. Otherwise, we put the token back and just return left-hand side. And yeah, so we parse the right-hand side with the same precedence as we are. Okay, so we have a problem in here. Any value, something, something, I don't quite understand why it has to do with any values, but okay. So OP token is supposed to be... Oh, yeah, okay, I see. So... I think I have to do something like as binary OP, right? As binary OP. Is it going to be fine? It seems to be compiling. Okay, so there's no any errors in here, and everything seems to be fine, right? Hopefully. Okay, so let's actually try to. I think this is the entire fix. To be fair, this is the, like how you add the precedence to your parser if you have parser implemented in a similar way. Right, so the entire sort of scheme of you know, supporting the precedence is basically this. I think I didn't make any mistakes. If I did, please let me know, and we're also going to quickly just check it out. So I'm going to compile expression 1 + 2 multiplied by 3, right? So we might as well even print the entire thing, right? We can print the entire expression. Maybe we're going to do src. All right, so this is src, then expression, the compiled expression to src, and then the value, right? The value of that expression, run expression expr. And I want to actually print all of these things separately, right? So it's going to be console log src. src, and then we're going to have expression, and then we're going to have a value. There we go. This is not how you print the value. This is how you print the value. All right, so let's go. If I try to run this, so the final expression is this, right, source of the expression, 1 + 2 + 3. So it got parsed like this. So at the root, we have plus, and then at the left-hand side, we have a symbol, which is correct, right? So, and then at the right-hand side, we have another binary operation, and it actually doesn't print this entire thing fully. And I think I know why, because console log is Pepega. So you have to do something like console log expr. And only then, I think, even then it doesn't print this entire thing fully. I don't remember how I made it actually print the entire thing. Yeah, it doesn't want to print this entire thing. I don't know. I already forgot. But in any case, so this value is correct regardless of what's the expression, right? So you have source like this and you have 7. So now if I swap these things around and let's see what's going to happen. Is it still going to be 7? It is still 7. It is still 7. But if you wanted to evaluate as something else, for example 8, you can explicitly add parentheses, and in that case it's going to be evaluated as 8. So we managed to add the precedence to the parsing. We managed to add the precedence to the parsing, and the issue is finally fixed, hopefully. If I made any mistakes, please let me know in the comments below. So let's actually make a pull request. All right. So furthermore, I want to actually test that I didn't break the whole website. So if I recompile everything just in case. So I can also go to emote gem and do Python 3 HTTP server 69. There we go. And I'm gonna just open this entire thing in here. So here's the website. I think I didn't break anything, so I'm gonna open the feature params. I'm gonna try to modify some things. So this thing is gonna be actually moving very, very fast. The scale is gonna be very big, jump height is gonna be very small, and the amount of hops is gonna be, yeah, it's gonna be 2. If I try to render this entire thing, is it looped perfectly? Yeah, it seems to be looped perfectly, so I don't think I broke anything per se. Let me actually try the original filter. Everything is looped perfectly. Okay. So, and let me take a look at the console. Console doesn't have any errors by itself. So, yeah, I guess we can finally safely commit this entire thing. So not 69. Make the expression evaluator respect precedence, right? I hope I spelled that correctly. If I didn't spell that correctly, I really apologize for that. Okay, let's make a pull request. Super quick. So I'm gonna copy this entire thing in here, and this entire thing is gonna close that. All right, how many changes did we make? Not that many, to be fair, not that many. And TypeScript checked all the types and stuff like that. All right, so that's it for now. Thanks everyone. I hope you enjoyed this small session, half-an-hour session. Check out the links in the description. So yeah, thanks everyone for watching. See you on the next session. Love you all. Mwah.